Hello and welcome to this video lesson. The focus of this video is linear regression. We're going to start with this question. It says the following is the temperature of Mr. Shatteri's tea in a cold winter day. And it gives us the time up here and it gives us the temperature down here. So the first question is to identify the dependent and independent data and to plot the data here, and then to draw the line of best fits. So in this case over here, we know that as time passes, the temperature is going to change, and that's because the temperature outside the ambient temperature is colder, so that would affect this over time. So our dependent variable then depends on the independent, and in this case our independent variable is the time, and our dependent is the temperature of the tea. And we can see that the keyword identify means to pick between different choices. In this case, our choices are dependent and independent, and here we have selected the right solution. So the next thing is to plot the data here. So here we're gonna actually have to figure out scaling in the x and y axis, name of the y and x axis, the title, and then start plotting the data. Okay, on our y-axis is where the dependent variable goes, and our temperature goes up to temperature of 70, and our minimum temperature is 34. We have about 15 ticks here, and it seems like we can actually choose every 2 to be 10. So I will do that with right here. So we got 10, 20, 30, 40, 50, 60, and 70. And this kind of allows us to use the whole y-axis, and it's really nice this way. We'll label this as 0, and I will label the y-axis as temperature, and put my unit as degrees Celsius. And on the x-axis over here where the time goes, there's also 15 tick marks, and our minimum value is 0 and our maximum is 12. So we can just go by ones, and I will just go 2, 4, 6, 8, 10, 12, and 14, and that covers the whole spectrum. So this I will label as time, and our unit for time here is minutes. The title of our graph is going to be the relationship between T, temperature, and time. You don't actually have to put in the units. The units are already here and here, so no, you don't need to say temperature in degrees Celsius and time in minutes. Our next step is to plot the data. So when we have 0 degrees, when time is 0, the temperature is 70 degrees. So at time 0, when this time is 0, we have to go up to 70 and put a little dot over there. And then when time is 4, so when time is here, the temperature is 60, so I will go up to 60 and put a dot right there. When time is 7, my temperature is 50, so I will need to put a dot right here. When time is 10, my temperature is 40. So I will put a dot right here. And when it's 12, my temperature is 34. So 35, 34 is approximately here, and I'm kind of estimating this. It's not very exact. And finally, I have to draw the line of best fit. And draw line of best fit is a straight line that tries to go through all the points, and if it can't go through all the points, it will try to model the points as best as possible. In this case, my line, if you can see, will kind of go like this, and I don't actually have a ruler that I can use with this application at the moment, so my line won't be very straight, but you folks can actually draw this using a ruler. And I did my best to draw a straight line, and you can see that it's a little bit curvy, but if you use a ruler, it will be fine. Now, we've answered the first question. The second question says to use the line of best fit to find the equation of the line. So we're trying to find the equation of this line, and it gives us a hint over here. This hint isn't always given to you, but you need to pick 2 points from the actual line. So you can't use any of these individual points unless the point is exactly on your line. And you can see that my first point over here is not actually on my line of best fit. The second one isn't, so I can't choose any of these 2 points. This one lies exactly on it. This one is really close. This one is not really, it's a little bit below. So I will choose this point, and I feel like the only other point that's really nicely on it is actually this one over here. So I will choose these 2 points. I will write their coordinates on the actual graph. So this point over here is when time is 6, my temperature is 50. And for this point over here, when time is 10, my temperature is 40. Once again, the point needs to be on the line of best fit, so this point, and this point cannot be selected, and we're lucky in this case that we have 2 points that actually are on the line. If they were not, we couldn't actually pick these points. We had to choose another point over here. So let's use those 2 points to find our equation of the line. So for my equation, my slope is change in y over change in x. In this case is change in temperature over change in time. And I will call this one as, I'll just use x and y's. It's a little bit easier. I could use t's and t's, but it's confusing whether you're using capital or lowercase t. So this will be my x2 and y2. So I'll write the equation down, y2 minus y1 over x2 minus x1. In this case, my y2 is 40, my y1 is 50, and my x2 is 10, and my x1 is 6. So I get negative 10 over 4, which simplifies to negative 5 over 2. And I can keep this as a fraction in this case, or I can put it into 2.5. They're the exact same thing in this case. I like to keep things as fractions, so I'll keep that as negative 5 over 2. Now, I know that my equation is y is equal to mx plus b. I've already found my m value as 2.5, or sorry, this should be negative 2.5, or negative 5 over 2. And this is x plus b. So I can choose one of the points on my line and find my b value. So I will use, and it doesn't matter which point you use, I will use point 1040. And again, you could choose 650, or you could use this point, you could use any other points on your line. It doesn't really matter. In this case, I've chosen this one over here. So in this point over here, this value is my y and this one is my x. So I will replace the y with the 40 and the x with 10 and solve for my unknown, which is the b. So 40 will equal to negative 5 over 2 times 10 plus b. Again, 40 is my y value and 10 is my x value. So 40 will equal to, once I do the math over here, I get negative 50 over 2, which is negative 25 plus b. And if I solve for b by multiplying adding 25 to both sides, I get b is equal to 65. So my final equation will be y is equal to negative 5 over 2x plus 65, and you could also write this as negative 2.5x plus 65. I'll write or, and I will highlight or box my final answer. Now, you can see that because we have, when we were drawing the line of best fit, we actually have to make an estimation. This is not a perfect line. So when we find our equation, this is not going to be a perfect equation at all. It doesn't mean that this equation represents this set of data really well, but we kind of made some estimations on the dot. We kind of made some estimations when we were plotting, when we were actually drawing line of best fit, and also the points that we have chosen are not perfect. So our equation here is based on what we did. This is the equation that we got. So now the next question actually asks us to estimate the Pearson correlation value. If you remember correctly, the Pearson correlation value is a value between negative 1 to 1, and it represents how close your points are to your line of best fit. So in this case, actually not in this case, but in general, if your points are very close to your line of best fit, the value will be closer to either 1 or negative 1. And if your points are really far away, so if you had points like all over and your line of best fit was going like that, then you would get a value of Pearson correlation value which was much closer to 0. So if it's closer to 1 or negative 1, that means that the points are very close to your line of best fit, and if they're far away, that means that it's closer to 0. If it's a negative value, it means that your correlation is negative. So as your independent is increasing, your dependent is decreasing, which is the case over here. And if it's positive, that means that your correlation is a positive correlation. So in this case over here, first of all, we know that our correlation is negative, so we know that our Pearson correlation value will be negative. And again, we're estimating. This is not a very exact value. And we can see that our points are actually extremely close to our line of best fit, so it will have to be very close to negative 1, but it's not exactly negative 1 because not all our points are on it. So I will estimate this as negative 0.99. And again, you could say negative 0.9, you could say even negative 0.8, but if you had said negative 0.5 or negative 0.2, that would not be a very good estimation based on the data that you have over here. So in the last part of the lesson, we try to model everything by hand, but we can actually do this using technology. And here I will try my best to put the two links for the TI-84 Plus and the TI-nspire CX down in these two sections. And if it doesn't work here, I will actually put it in the description so you can actually use those links to figure out how to use your calculators to get to this point. Here the question again says use technology. When it says use technology, then you have to use your calculator or Excel or other resources to determine the equation of the line and the Pearson's correlation. So watch the video, whether you have the TI-84 or whether you have the TI-nspire, watch the video that you need to watch in order to figure out how to actually find the equation. And I'll just show you what information you have to write down once you use your calculator in order to show your work. Alright, so here I have attached the photo that I got from the TI-nspire, and again, you can't attach a photo on an actual test to show your work. So here the information that we're gonna write down, one of them is going to be the slope. So you can actually write using GDC. So I'll just erase this for a second, and I'll write using GDC. GDC stands for Graphing Display Calculator. M was equal to negative 3.05, and I will just write in three significant figures. B was equal to 70.9, and the R value was equal to negative 0.998. Again, everything in three significant figure. Therefore, the equation of the line is y is equal to mx plus b, so my m value is negative 0.35x plus my b value, which is 70.9. And if you want to be more exact, you can actually write this as an approximation, because we're actually approximating these values because we're not writing all the significant figures. And so I'll just erase this just to make it look a lot more like... There we go, approximation. So y is approximately 3.05x plus 70.9, well, negative 3.05. And the Pearson's correlation is negative 0.998. We are not asked to do this, but if we were asked to comment on the strength and direction of the correlation, we can say that based on the Pearson's correlation, it's strong because it's close to -1, and it's strong negative correlation. And it's negative because it's a negative value, and that means as our dependent variable is, as independent is increasing, our dependent is actually decreasing. Now, the second part of the question is interesting. It says hence. Hence means you have to use the information that you obtained from the previous question. Hence, calculate the temperature after 2 hours. We can see that our equation of the line, in our equation, y represents the temperature and x represents the time. So we can also write that here. So y is temperature and x is time. So in this case, we are looking to see what the temperature is at time 2 hours. And if we look here, we can see that the time is given in minutes, so we have to turn our 2 hours to minutes. So 2 times 60 is 120 minutes. And then all we do is we plug it into our equation. Y is equal to negative 3.05 times 120 plus 70.9. And we plug this into our calculator, and we get approximately negative 295.1. I'm just going to write it as three significant figures, so negative 295 degrees Celsius. Now, right away when we see this, we realize that, oh, there must be something wrong with this. Negative 295 degrees, that's very cold. And the temperature of the tea in a cold winter day, a winter day will not be negative 295 degrees Celsius. at least not right now on Earth. So we are not going to, well, it does say that this model isn't the best model to, it is a good model within our range of data, so it's actually nice to do interpolation, but it's not very good when you start to extrapolate, especially as you get further and further away from the time that we have. So our time here is between 0 and 12 minutes, but 120 minutes is actually very, very far away, and usually our temperature should reach the ambient temperature. This case, if the T is left outside, let's say the temperature outside was negative 40 degrees Celsius, after 2 hours or after 3 hours, the temperature should be approximately negative 40, but definitely not negative 295. So here it says comment on any limitation of the model. We can actually say it is not a good model when we extrapolate as shown above. The model predicts a temperature of negative 295 degrees Celsius after 2 hours, and this is not possible unless the ambient temperature is that low. And you can also add that typically ambient temperature depends really on which country you are at. So it could be, you can write anything between even, let's say, negative, it could be lower than this, but let's just say negative 50 degrees all the way to, it could be, even if it's winter in some countries, it could be pretty warm. So I'll just write 20. So this is kind of the temperature that it should be at. However, after 2 hours, it's saying that it's negative 295, and that's a little too cold for our temperature. And again, you can write other limitation of the model as well, but in this case, the obvious one is the one that we actually found from the previous question. So I hope this video gave you some good ideas about how to use your calculator to find the equation of the line and how to use that set of information to answer real-life problems and how to talk about limitations of your model. Remember that every question will be different and every model will have different limitations, so you need to keep that into consideration. And make sure that you know how to use your calculator to find the equation of the line. And again, linear regression is kind of using a model to represent the data, independent and dependent data. And here we're using a linear one, and we're getting y is equal to mx plus b, and that's kind of our the model that we're using over here. So again, make sure that you understand how to use your calculator to plot the data and to find or to analyze the data in order to get the r value, to get the slope, and to get the b value or the y-intercept, and in order for and make sure you can use that set of data to answer the real life problems.